So we left off last time. We merged and reprojected our our TIFF files into a single reprojected DEM. Now we're going to save these files and we're going to import them into Oasis Montage in order to create our terrain correction grid so that we can perform a terrain correction on our gravity measurements. So what we're going to do here is we're going to make sure that these are indeed in the right coordinate system, and they are. Right up here you can see 6340, and for this one as well, 6340. Oasis Montage has a little quirk, and for whatever reason it doesn't like other image files that aren't .ers. So you can't do a GeoTIFF or some other raster image, raster format that has information on it. It has to be in a .ers. So we'll start here with the 10 meter DEM. We're going to export and save as format. Remember, not GeoTIFF. We're going to go down to ERM or ERMapper.ers labeled, and that's what we're going to save it in. And we're going to save it to, wherever's convenient. So I'll save this here. I'm going to save it as 10 meter local DEM as .ers. Okay. And we don't need to make it it doesn't need to be exported as a, oh, it doesn't do that anyway. Yeah. Oh, there we go. That's what we don't need to do. We don't need to add the saved file to the map. It's unnecessary. You can unclick that or deselect it, and it'll just save this .ers in the file folder, and it won't populate anything under layers in QGIS. So that will be our 10 meter. And then we'll do the same thing here. Right click, export, save as, not GeoTIFF. We want it as .ers. We're going to point to, well, it's already the same folder, and this one I'll do 30 meter regional DEM. And we're labeling it local and regional because that's how we'll know which column or row to populate in Oasis Montage when we get to that step. And I'll show you what I mean when we get there. But for now, make sure you label the 10 meter as our local and our 30 meter as our regional. And we're going to save these both. We don't need to add the save file to the map. We're in the right format. Everything else is good. Okay. We're done with QGIS in terms of exporting our DEM files. Next, we're going to pull up Oasis Montage. And I have all the databases and grids are down here. That's why it's gray up here. And we're going to create our terrain correction grid. So we're going to go up here to gravity. We're going to go here to terrain correction, and we're going to create a regional correction grid. And this is why we labeled it regional and local, because we don't want to reverse these, otherwise the terrain correction will not work. So for our regional grid, we're going to point to the file we just saved. So we're going to go to ERS, and we're going to switch from .grd to .ers right here. Make sure you do that, because otherwise you'll spend forever looking for the incorrect file, and you will not find it because we saved it in a different format. So make sure you change it to .ERS right here. And for the regional, that's 30 meters. That's the larger 167,000 kilometer DEM that we created. We're going to open that. And our local DEM is going to be the 10 meter one. Again, don't forget to switch it to ERS and 10 meter. Our output terrain correction grid, you can label this however you'd like. I'll put it in the same file. And this will just put in the DEM still, but I'll label this TC tutorial. And that's where it should save. Okay. Our terrain density and water, well, the water density is always going to be 1. The variations in density as temperature decreases isn't enough to affect our water density overall, or what the average is. And the terrain density that we're using is 2.67. There will be instances where we will change this terrain density, depending if we're on sediment, what kind of sediment it is, versus whether we're on bedrock or other layers. But for general purposes, 2.67 is fine for this. Our outer regional correction, so our regional correction distance is 167,000. Our inner or local correction distance is 2,000. So 167 kilometers and 2 kilometers. I usually leave this as faster. You can do none, but why not? And then the survey, you can hit scan. And this will take our X and Y min and maxes from our database, from the master database, and it will use those as our X and Y values, if I remember correctly. Perfect. Okay. And it's a ground survey. That's defaulted to ground survey. And then we're going to hit OK. Now, if you do something wrong, or the scan XY doesn't work, or it's pulling data X and Y from the wrong database, this terrain correction will only take a minute or 2. If the scan XY is bounded correctly, and we entered or we inputted our DEM regional and local correctly, then you will have a longer time remaining for your correction, or your terrain correction grid. As you can see here, I have 30 minutes, and that's about right. I mean, that's typically how long it takes for my computer to process the terrain correction grid, given all the inputs. This number is highly variable depending on the processing power of your computer. For example, I believe when Chris ran the same correction grid, his was 45-50 minutes to perform the terrain correction. So it is process intensive, and instead of sitting here for 30 minutes rambling on, I will stop here, and then when we come back, we will have our terrain correction grid ready to go, and we can perform our terrain correction. Okay, sweet.